Well, today our goal is that we can factor polynomials using something we call the GCF. All right, so let's talk about what that means. First of all, GCF stands for the greatest, write that down, common factor. It's going to be very important throughout our whole factoring process and this new unit we start. Now, we got to understand really what is factoring. Well, there's a lot of technical definitions, but a working definition is it's kind of undoing or the inverse of distribution in polynomials. So we're kind of undoing what we've been doing here when we were multiplying. We're reversing it. The abbreviation for greatest common factor is GCF. And the greatest common factor is the largest number or variable that can evenly divide all the terms. So the greatest common factor is the largest number or variable that can divide evenly into all the terms. Now, it's really important to note here that as we are going to be doing various types of factoring throughout Unit 9, the greatest common factor will always be the first step in factoring. So that's a pretty important piece there. The greatest common factor is always going to be our first step when we factor. All right, so I just want to look at a few quick examples to get you started. Talk about how we're going to go about it. So for this first one, I want us to factor, using the GCF, 84 x to the third plus 36 x squared, okay? So the first thing we'll do is to find the GCF. Okay, the number or the variable that will divide evenly into 84x to the third and 36x squared. Now, here's the thing I know, and this is logical if you think about it. The factor that will divide into both of these will not be any larger than 36, because if it's larger than 36, it won't divide into 36, will it? So what I'm going to do is I'm going to first look at all the factors, everything that multiplies to be 36. For example, I know that 36 will be 1 times 36, right? Okay, now notice how I'm approaching. We'll start with 1. Now, 2 times 18 is 36. So what I'm writing down is simply things that multiply together to equal 36. So 1 and 36, 2 and 18, these are factors of 36. So 2 times 18 is 36. 3 times 12. Now, if I need to use a calculator, I can. I'm not going to for this, but I could. 4 times 9 is 36, isn't it? And then the last one is, let's see. So I did 1, 2, 3, 4, 5. 5 won't divide into 36, will it? But 6 will. And that's 6 times 6. Now, I don't need to keep on going because I've covered everything from 1 to 6. And at 6, it was 6 times 6 that gave me 36. So the next thing will be, 7. Well, we know 36 will divide by 7 or 8, but it'll divide by 9. I've already got that covered. So now what I'm looking for is which one of these factors, 1, 2, 3, 4, 6, 9, 12, 18, 36, will divide evenly into 84. Once I find that, I found what I'm looking for, the GCF. Okay? So what I might do is I might even, if I'm not good with dividing by 84, and a lot of people might not be, I could just, put that into a calculator. I could say 84, I know it might divide by 2, so does it divide evenly by 2? Well, it does. Does 84 divide evenly by 3? Sure does. How about 84 divided by 4? Yep, it does. 84 divided by 6. Yep, it does. 84 divided by 9. Oh, now that doesn't divide evenly, does it? Keep moving. 84 divided by 12. 7, okay? 84 divided by 18. Nope. 84 divided by 36. Nope. So the winner is 12. Now remember, I'm trying to find the greatest common factor, the number that will divide both 36 and 84, and I want the greatest one. In other words, I want the largest one. All right. So the greatest common factor then is 12. Now, I'm not yet done because it also is the greatest variable factor. Well, remember that x cubed is x times x times x, and x squared is x times x. Okay? So here's what I see there. Here's a shared factor. Here's a shared factor. So the greatest common factor in terms of my variable is x times x, which is x squared. Can't say x cubed because that wouldn't divide evenly into x squared. So the greatest common factor here I'm looking for is 12x squared. Now I'm going to go back and I'm going to rewrite it in factored form. In other words, I'm going to take 84 and divide it by 12. and that is 7. Okay, so I'm going to write it this way. I'm going to write my greatest common factor out front. Remember, I'm kind of doing the opposite of distributing, so I'm undoing it. And so 12 times 7 is 84. X squared times x would be x to the third. Okay, that's pretty easy. 36 divided by 12. 36 divided by 12 is 3. And x squared divided by x squared is just 1, so I don't have to worry about the variable at all. So in factored form, my answer is 12x squared times 7x plus 3. That's not too bad. Let's look at another example. So this example is this. We want to factor example 2. We'll factor, we'll up it the difficulty a little bit. It's going to be 4x squared y minus 10x to the fourth y squared plus 6x y to the fourth. So step 1 is to find the GCF. Well, all I need to do is look at the smallest coefficient, 4, 10, and 6. The smallest one would be 4, right? Let's talk about what are the factors of 4. All right, well, the factors of 4 are 1 and 4. And then 2 times 2, well, hey, it's repeated there. We won't divide by 3. So the factors are 1, 2, and 4. Well, 4 divided by 1, 4 divided by 2, 4 divided by 4. We can figure that out. 10 will divide by 2, and 6 will divide by 2. Will 10 divide evenly by 4, though? No, nor will 6. So the number I'm looking for there, my greatest common factor, is 2. Now, really, when I go to find the variable portion of the greatest common factor, I'm just going to take each variable to its lowest exponent. You know, if I look at this, I have x squared, I have x to the fourth, and I have x. So my greatest common factor has got to be x. And then I have y squared, and y to the fourth. So the smallest exponent is just y. So my greatest common factor is 2xy. So I can rewrite it this way. It's 2xy. Now, let's go through and divide. So here, 4x squared divided by 2xy. 4 divided by 2 is 2. X squared divided by x, x, y divided by y, 1. Then, negative 10 divided by 2, negative 5. X to the fourth divided by x, x to the third. Y squared divided by y, y to the first. Last, 6 divided by 2, 3, x divided by x, 1, y to the fourth divided by y, y to the third. Again, all I have to do with the exponents is if I'm dividing, subtract the exponents of the variables. So I have this completely factored. Let me throw one at you that you might think is easy. Looking at it right offhand, I want you to factor 3x squared minus 5. All right, so the first thing to find out is the GCF. So the smallest number here is 3. Factors of 3 are 1 and 3. Will 5 divide by 1? Yes. Will 5 divide by 3? No. So it appears that my GCF is 1. Is there a variable portion I can factor out? Well, this has an x squared. This does not. So there isn't. So again, my GCF is 1. If my GCF is 1, my greatest common factor is 1, then we will call that factor or that polynomial, we'll call it prime because it cannot be factored. So let's define that just for a moment. If the GCF equals 1 and no other, throw that in there, no other method of factoring. Of course, at the moment, we only know one method. So if the GCF is 1 and we can't factor it using any other method, then that polynomial is prime. So factoring with the greatest common factor is fairly easy. We can factor most any polynomial with the greatest common factor, and that's going to be our first step. Even when we're doing other types of factoring, we want to check for the greatest common factor first.